Hello, Math 20-1. So, just so we're clear, you are already done this lab, and the only thing you're coming back is maybe you're away from class and you want to uh, make sure you haven't missed anything of the takeaways. So you've already done this lab, you've used your graphing calculator. What was it that you needed to get out? Well, if you look over here, what we've got over here is we've got a discussion about vertical shifts and horizontal shifts, and this is about vertically stretching. And so what you saw as you played with your graphing calculator is you saw some of these things being done to the basic quadratic function. The most basic quadratic function was this. And as you went through this unit, you would have seen some things if I just gave you some examples. So for the Q one, you might have seen some things like this, x squared, y equals x squared plus 3, or y equals x squared minus 5. You would have seen y equals, instead of x squared plus 3, x minus 3 squared, or y equals x plus 5 squared. And you would have seen some examples of the a's as y equals 3x squared, and maybe y equals 1/2 x squared. Those are A, P, and Q transformations that can occur to a parabola. And you should have learned what each of those looks like and how it works, okay? We'll talk more, but if we just use this first example, if I have this first line, let's call this line line 1, and somebody says to me, yo, I want you to take that line and I want you to put it right on top of line 2. Well, you have two options. You could take these points right here, these blue points, and one thing you could do is say, yeah, you know what I'm going to do? I'm going to move all those points to the right 2 units. So if I put this point, actually 1, 2, 3 units. If I move all the points right 1, 2, 3 units and 1, 2, 3, then this line is now on top of that one. So how could you move one? Well, you could say, I'll take line 1, move 3 units to the right, gives L1 on top of L2, right? That would do it. Or you might say, no, 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 that's not what I want to do. What I think I could do is I could take that line, and instead of going 3 to the right, can you see another option? What we could do is, instead of doing that, we could take it and line 1 go 3 units down. And if I took every point 3 units down and I drag this line down and down and down, I would be on the same. So you could also say, just take the green option, line 1 gets moved 3 units down, and that would create the same line. So if you think like a Math 10 student, you would say, well, how could you change one of the lines? Well, we could simply take our y equals, how could you change the equation of one line so that it gives or coincides the other line? Well, we'll just take y equals the line x plus 1, and if we subtract 3 from that to move it down, then we just end up with the same equation, y equals x minus 2, which is the same equation that you have for the other line, okay? Now, what I want to do, let's just cover up all this stuff here, and, well, let's just do this. I want to pause. Okay, so I'm just covering all that. What the essence of this unit is, and I really, really, really want to focus on, the essence of this is you taking this basic problem. And the most important thing for you right now is to know the critical points that you're going to have on a basic problem. And so I'm just going to highlight these. So when you do a basic problem, when you plug in 0 into y equals x squared, 0 squared gives you 0 squared gives you, so I'm just highlighting, 0 squared gives you 0, and 1 squared gives you 1, and 2 squared gives you 4, 1 squared gives you 1, minus 1 squared gives you 1, and minus 2 squared gives you 4 as well. So those are the critical points. So the question now is, when you transform these, when you transform these points, what will happen? Well, in this, you should see those points getting moved up and down, or you should see them getting moved left and right. And you need to come to peace with what it is you need to do to the equation to make those things happen. Okay, so let's just look and see and go through this investigation and see what you got out of it. So if you were to just play, and this was my self playing, if I play with this investigation about Q, so maybe that's a lot for you to see. So if I'm just looking at the first one, pick some values of Q. You don't have to pick mine, but if I picked Q as 0 and Q was 4 and Q was -3 and I graph it on my calculator, what I see is that the graph moved up and down. If Q is positive, it moved up, and if Q was negative, it moved down. That's what I saw. Those were my equations, right? Those are my equations. If Q is 0, it was y equals x squared. If Q was 4, I got y equals x squared plus 4. And if Q was -3, and notice that I got these as my graphs, right? I graphed them. Right? How does it change? Moved up and down. On the second one, it said, hey, go into this and change values of P. All right, so I'll change values of P. So the first thing you do is you pick, well, if I pick P to be 4, and then I stuff it in my calculator, I put P as 4, and I got x minus 4 squared. I put P as -2, and I got x plus 2 squared. And if I had P equal to 0, so I would just have x squared. So when I graph them, and look at I graphed them, I got, when I graphed, and again, we'll just highlight. When I graphed x plus 2 squared, well, that was over on the left too. When I graphed x minus 4 squared, that was over on the right 4. What's my conclusion? My conclusion seems to be that the p-values seem to move things left to right. When I see x minus 4 squared, that went 4 right, and x plus 2 squared moved it to left, and 0 meant that it just stayed still. Well, that's cool. What about our conclusions? Well, it seems like it's the same shape, congruent shape, but it moved it left and right. So our next investigation, and we'll cover this up, is about A. Play. Go to your graphing calculator and try different values between 0 and 1. What are values between 0 and 1? 0.1, 0.2, 0.5, 0.8. Choose values between 0 and 1. What I found was when I plugged values between 0 and 1, I got parabolas that were smaller than what I had. So just play with this one, and we're going to look at the big picture. So I tried a bunch of them. You can see I graphed y equals minus x squared, y equals 2x squared, y equals 4x squared, y equals a half. And I noticed that it basically, if I could put a big point, all these parabolas were still anchored. It ends up looking like a spider. It ends up being there, and they just seem to get stretched or squashed, but their vertex did not change. All right. So now we have this chart that you would have completed, and here was mine. So when I look at what's happening in each of those, in the first one, I'm asking you to do something extra. I'm asking you to fill out A, P, and Q. And so when you look at the first one, A is 1, P is 0, and Q is 0. There are no P and Q. What happens to that? Well, it is just, it's our basic parabola. This is the most basic one. So part 1, that's the most basic one. In number 1, well, I can see that, in number 2, I can see that the A value is 1, the P value is 7, and the Q value is 0. What did it do? Its direction of opening, it's a happy parabola. Its vertex is 7 to the right. Its axis symmetry is x equals 7. And is it congruent? By that it means, is it the same shape? And yes, it is. It's not been stretched. Nobody grabbed onto its arms and put it on a rack and stretched it. So it is the same. Y equals x plus 8. What happened to that? Well, it's up. Its vertex is left. Yes, it went left. Its axis symmetry is x equals 8, and so on. Okay. The fourth one, it went up. Its direction of opening up, it went up 7. it's still anchored at x equals, axis symmetry is x equals 0, and it hasn't been stretched. The next one, it went down 8, right? Went down 8. This one, its opening is up, its vertex is 0, 0, but it's not the same as x squared because it has been stretched. It's stretched long. No, it's really stretched long. And lastly, it's minus 7 squared. This one is sad. It's 0, 0. And no, it's been stretched long downward. It's not congruent to our first parabola. All right? As you continue on and you go, well, on grid paper, can you graph this without using a table of values or a graphing calculator? And I think you can, because here's what I want you to do. What I want you to do is just say to yourself, self, I know what the basic parabola is. 1, 1, 0, 0, and 2, 4. So 1, 2, 3, 4. Okay, so here's my basic parabola. What I need you to realize is when you look at this, what did this do? This went up 5. So what I want you to do now is just go up 5. Move all these points up 5. So instead, I'm just going to go 1, 2, 3, 4, 5. I go up 5, and I say, well, if I went up 5, this point here got moved up 5. This point here got moved up 5, so it'll be right there. And 2, 4, this point will look like that. So there's my critical points. All of them moved up 5. What happened to this one? This one went down 4. So that's easy. Just go down 1, 2, 3, 4. And what you could do is just draw the critical points on this new set of crosshairs. So 0, 0, 1, 1, minus 1, 1, 2, 4. And I know those aren't actually the points, but what I'm doing is just moving all those critical points I had before down 4. Okay, so I just drew it without actually using my calculator. With this one from my learnings in my lab went left 3. This one went right 5. So I know my critical points. Oopsie. I know my critical points are supposed to be, we'll start with blue, 0, 0, 1, 1, and 2, 4. 1, 2, 3, 4. Okay, so this would be my basic parabola, right? So I go down and up. Those are my basic points. What would happen if I moved everything to the left 3? Well, I would just go and move everything left 3. So 1, 2, 3, that would be now my vertex, and it would go like this. And there's my new parabola. That one went left 3. And what if I went to the right 5? Well, I'll just put it right 1, 2, 3, 4, 5. There's my new vertex, and 1, 1, and over 2 and up 1, 2, 3, 4. So there's my parabola that went to the right 5. So you don't need a graphing calculator for this. The trickiest one of all is the stretch. Y equals 2x squared and a half x squared. Again, let's do our basic parabola. 0, 0, 1, 1, 2, 4. And now we graph it. And we say to ourselves, we need to stretch that. Oh my. So this, I'm just going to draw this. If I'm going to do 2x squared, this will vertically stretch. Somebody grabbed onto the arms of this parabola and vertically stretched by a factor of 2. That means that the vertex doesn't change. This guy is like the anchor. And this is 1. That point there now becomes 2. This point was 4. Now that point becomes 5, 6, 7, 8. So this parabola is now twice as tall as it was before. It's now twice as tall. That's y equals x squared. Y equals a half x squared. If we do that in a different color, y equals a half x squared will be half as tall, vertically stretched by 1/2. And therefore, if I do those in red dots, this point is half as tall. This blue point that I didn't draw very well, that was 4 units high, will now only be 2 units high. And this is a half, and this one is 2. So now you can sort of see that a parabola that's half as tall will be vertically stretched. Some would call that compressed, but we're not supposed to say that word, okay? And I didn't use my calculator, I just used my blue dots. And minus 4x squared and minus 1/4, again, 0, 0, 1, 1, 1, 1, 2, 4, 2, 4. Those are my basic, see, that's my basic parabola. So if somebody does minus 4, whoa. If somebody does minus 4 and we do that one in green, this is vertically stretched by a factor of -4, meaning that it will be -4 times as tall. So this point right here, I'm going to put the green, multiply that height, that's a y value of 1, multiply that by -4, and it's going to go right there. Whoopsie, not there. It's going to go right 1, 2, 3, 4, -4. Now the other one's going to be -16, but I can't draw that one, so that's going to be 4 times as tall. This is y equals -4x squared. 4 times as tall, but sad. And y equals -1/4, the green one, y equals -1/4 x squared, that's going to be vertically stretched by -1/4. So I'm going to use these 2 points, and when you multiply 4 units tall by -1/4, they become 1. So that point that used to be 4 units high is now -1 unit high. And so this parabola is very much squished. It's not nearly as, it's sad, and it's not nearly as tall. Okay, so that's what the A value does. And now you have the answers to these in the back, so you guys can finish that off. Okay, so that's your lab, and we're going to carry on with that as we graph functions in the next section, which is 4.4. Okay, we're going to take these learnings and use them. All right, ask questions tomorrow if you need.